Yes, sir.
Yes, sir.
राइट। तो आपका टेक्स्ट बुक एक बार देखो बेटा, गेलुसा क्लॉ। This we are discussing, right? So this part we are going to discussing Gay-Lussac's law, right? In which pressure is directly proportional to temperature. In Charles' law, volume is directly proportional to what actually? Temperature. Now when temperature is increased, volume also increases. And according to Gay-Lussac law, when you increase the temperature, pressure is also increasing here. And this is at constant value. Whenever if you plot a graph at constant volume, that is called what? Isochore. When you plot at constant temperature, what we call better? At constant temperature, what we call that one?
Isotherm.
What we call? Isotherm. At constant pressure?
Isobaric.
At constant pressure? Isobar. At constant volume? Isochore. Okay. So these three are very, very, the one is therm, means what? Temperature. Bar means what? Pressure. Core means what here? Volume. Now this is about the Gay-Lussac law. At constant volume, pressure of a gas, isn't it? Of a fixed amount of gas. Here also moles are what? Constant here. The mass of the gas is also what here? Constant. It's directly proportional to the temperature. Now, when you plot a graph between pressure and the temperature at this constant value, at constant V1 value, you are going to get something what happened? Temperature increasing, pressure also increasing. And take its second value, say other value you take. The volume of the gas will change again. Again, at constant volume, pressure is increasing, temperature also. Again, you change the value and increase that value. And again, consider the change in the temperature and the pressure, both are what happen? Directly proportional. So if you do with this, what happen? V1, V2, V3, the volume from here to here, what happen? Increases. That means you are going to get a graph like this. That means what happen? You observe here it is what? More volume I have taken. Isn't it? V4 is what? More, right? More volume I have taken. In that case, the pressure you are going to get in this case, what? Low pressure. The pressure you are going to get to observe here, what happens? Low. Here I have taken what? More volume I have taken. Less volume, sir. Less volume I have taken. When you take less volume, what happens? The pressure is what happen here? High. The pressure, if you observe what happen here? High. That means what I'm saying here, when you plot a graph between pressure and the temperature at constant volume, this is a constant volume, pressure and temperature both are increasing, giving a straight line. And take second experiment in which the volume you are taken, increasing the volume, it is something around 1 liter. Now, next experiment you are doing at 2 liter. Next experiment, if you do at 2 liters, again, temperature is increasing, pressure is increasing, but the total pressure you are going to get, that one will be lesser when you compare with what? At 1 liter. I can do at 3 liters. Do at 3 liters. Now, entire experiment you are doing at what volume here? 3 liters here. The entire experiment, throughout the experiment, what volume you are making constant here? 3 liter. Understood here? The volume is constant. How much it is? 3 liter. You are doing experiment at what condition? 3 liter. Again, you are increasing the temperature and the pressure is increasing. But when you observe the pressure, isn't it? The high pressure you are observing, at last you are observing whatever the pressure you are observing at last, that is what? Low when you compare with what? V1. Understood better this concept here? V1, V2, V3, V4?
Yes, sir.
Right. Now let me see what happened. This is the formula we can directly we can write like this. Formula we can directly write like this here. Okay. P directly proportional to T, right? P directly proportional to T. Then you send this and remove this proportionality. What we get here? P is equal to KT you get here. Now in that case, P by T is equal to what? Constant. So based on that, what I can write here? T1 is equal to P2. This is the formula we can generate. Isn't it? Otherwise, you can also write P1 by P2 is equal to T1 by T2. This is the formulas you can write. So based on this formula, you can do n number of problems. Understood here? So for example, if you do this problem, shall we take one problem? A glass container is sealed with gas at what pressure? 0.8 atmosphere pressure. 0.8 atmosphere pressure. So P1 it is. And temperature is 25 degrees Celsius. It will be T1 is. This one will be the P2 as a pressure. Calculate the temperature to which container. So P1 we got, P2 we got, T1 we got. Now what is the formula beta? P1 by P2 is equal to T1 by T2. This is the formula. Now substitute everything. 0.8 as a P1. P2 is what? 2. And T1 is what? 25 or 298 we have to take beta. 25 you have to take or 298 you have to take. What temperature you have to take? 298. Always you have to convert degrees Celsius into Kelvin by adding what? 273. You are going to get here what? 298 Kelvin temperature and T2. Now T2 will be what here? Isn't it? 2 1s are 2 4s are 0.4. Therefore, you are going to get 298 by 0.4. 0.4 you can write 10 to the power of minus 1 here. Now how much it will be what? 2 2s are 4. 1s are, isn't it? 4s are 90s. 2 1s are. Something what happened? 2 1s are means 70. 7 it is. And it will be 9 means what I can, you can take 8. 78.5. And send this one, you are going to get 785 Kelvin temperature. I think 785 Kelvin temperature. The volume is constant. 745 Kelvin temperature. P2 is equal to 740 Kelvin temperature. Again, how to convert into degrees Celsius beta? By subtracting with 273, and this will be what here? In degrees Celsius. This will be in degrees Celsius. Understood here how to do the problem, everyone? Yes, sir. lussac law?
Yes, sir.
Yes, sir.
Right? Now, next, remember one thing beta. This V1, V2, V3, V4 will increase. This they are asking MCQ questions beta. In lussac law, V1 is greater than V2, which the following is correct like that they are asking. This way they will ask. So what will be the correct option? This will be. So remember this one. Next, if you go for what? Avogadro's law, which is very, very important for us. Okay, very important beta. Avogadro's law is very, very important for us. So what is this Avogadro's law? Very simple. It states that equal value, you see, it states that equal volumes of all gases under the same conditions of temperature and pressure contains equal number of molecules. That means in this we are doing that volume and number of molecules both actually we are taking in consideration. Volume and number of molecules. So when you have same number of molecules, the volume also will be same. To explain this one, what I am taking, I have taken hydrogen, I have taken helium, I have taken something what happened nitrogen, I have taken something oxygen. Now I have taken how many molecules? I have taken hydrogen, I have taken what? I have taken 6 into 10 to the power. Just imagine 6 into 20 to the power of 23 molecules I have taken. Here also same. How much I have taken? 6 into 10 to the power of 23 molecules. And here also I have taken 6 into 10 to the power of 23 molecules. And here also I have taken 6 into 10 to the power of 23 molecules. In all the cases, the number of molecules I am placing in a container is what? Same. In that case, all will have same value. So the volume occupied by the hydrogen is 22.7 liter. Here also what happened? 22.7 liter. All will occupy how much here? 22.7 liter. Because they are having what? Same number of molecules. But this pressure must be constant. If you change the temperature for hydrogen, if you maintain it something, what happened? 300 Kelvin temperature. But if you maintain helium at what happened? 400 Kelvin temperature. Then what happened? You can't say something helium and hydrogen will have same value. You can't say like that. So what is the condition, beta? Equal volumes of all gases under same conditions of temperature and the pressure contains equal number of molecules. Okay. So what is the constant here? Temperature and pressure must be what here? Constant. Understood, beta? Now, in this case, what happened? You already know molecules directly proportional to mole. For example, 1 mole carries how many number of molecules, beta? 1 mole carries how many number of molecules?
Na molecule.
Anybody? Na means how many number, beta? 6 into 10 to the power of 23. That means if you decrease the number of moles, molecules decreases or increases?
Decrease.
Instead of 6 into, if I take what happened 3 into 10 to the power 23, number of moles will increase or decreases?
Decrease.
Decreases.
Decreases. That means number of molecules and moles are directly proportional. When you increase the number of molecules, moles will increases. When you decrease the number of molecules, moles will decreases. So what I'm writing, in place of taking number of molecules, instead of taking the number of molecules, I will take number of moles here. Both are what? Same. See, for example, 1 dozen. 1 dozen is equal to 12. Correct or not? If I increase this one into 24, how many dozens I will get? 2 dozens. If I decrease this one into 6, how many dozens I will get? So instead of taking 6, I will take now dozen. Here also, instead of taking the number of molecules, I will take number of moles here. Now what I can write here? V directly proportional to N. V is nothing but here volume of the gas. N is what? Number of moles of the gas. So V directly proportional to what? N here. Right? Here thing is that the temperature and pressure must be constant. Here one thing important, if you maintain NTP conditions and STP conditions, 2 conditions will be there. NTP and STP conditions will be there. At STP conditions, 1 mole of gas always occupies 1 mole of gas, isn't it? Occupies 22.7 liter, 22.7 liter. At NTP condition, the same 1 mole of gas, occupies 22.4 liter. Why we are getting 22.4 liter? Why we are getting what's this 0.3 difference here? Because here in NTP condition and STP condition, what change you are getting here? What type of difference we are going to get? In STP conditions, standard temperature is, isn't it? The standard temperature is 0 degrees Celsius. That is nothing but what? 273.15 Kelvin temperature or 0 degrees Celsius. What temperature you are maintaining at STP conditions, beta? Isn't it? 0 degrees Celsius. Correct or not? Now pressure, what we are using here? Pressure we are taking as 1 atmosphere, 1 atm pressure we are taking. 1 atm pressure we are taking. But in this case, in normal temperature and pressure, NTP means normal temperature pressure, the temperature is again same. The temperature you are taking what again? Same. What much it is? Same thing, 0 degrees Celsius only, but pressure you are taking in terms of bars here, in terms of bar. Now here, 1 atmosphere is equal to how many bars, beta? 1 atm is equal to how many? 0.987 bars. 0.987 bar. How much difference you are obtaining here? 0.013 difference. So because of this 0.013 difference, we are getting here what? 22.4 liter actually. Okay. So almost the same, 22.4, 22.7, almost the same, but most of the cases will take STP conditions. Actually, in the previous books, what they use, STP will give 22.4, right? But it is actually, we can take, according to our textbook, we can take 22.7 actually. Why? Because according to this NTP STP conditions, how you got, from which law you got here? Have derived this one from which law, beta? Anybody? Anybody?
Avogadro.
Avogadro law, right? Very good. All right. Now let me see now what happens here. We derive some equation, a small equation by using the Avogadro's law. A small equation isn't by using Avogadro's law. What I'm doing here, I'm writing over here. All of you please listen here. Now V is equal to Kn, I'm writing. Kn, I'm writing. Where K is what happened? Proportionality based upon this formula. V directly proportional to N. Based upon this formula, we are taking V is equal to Kn here. Now already N is equal to mole, no? N is equal to what actually? Mole. It is mole. Now mole is equal to formula will be better. Mole is equal to what formula you are taking? Mass, mass, weight divided by what? Molar mass. Mass by molar mass. Now represent mass by what? W, otherwise small m. Molar mass by what? M. Weight by molar mass. Mass, otherwise you write weight also. You can write even weight also. Mass or weight. Okay. What is mole here? Weight of the gas divided by molar mass of the gas. For example, molar mass of the gas, nitrogen 28. Weight to take 1 gram like that. Now in place of this one, substituting here V is equal to K into N is equal to what here? W by M. Capital M it is, molar mass. W by M. This you got actually. Now one more thing you got, you know one thing actually. Density is equal to anybody, what is the formula? Weight by, what is the density formula by? Formula better?
Mass upon volume.
Weight by anybody? Mass by volume. Correct or not? Right? Now in place of this one, what we are taking here? Now send this one here and M over here. What I am doing here? M molar mass is equal to K into W by what this one actually? V. Now in place of W by V, what I can take here? M is equal to K into D. Now molar mass is directly proportional to density. Molar mass directly proportional to density actually. So this is the one more formula, it will be useful for you. That means molar weight is directly proportional to density. Higher the density, higher the molar mass. Now if you want to calculate molar mass of any molecule, what we have to do? Directly multiply 2 into with vapor density. Vapor density is nothing but density of a vapor. For example, what is the molar mass of nitrogen beta? What is the molar mass of nitrogen? Anybody? Molar mass of nitrogen? Molar mass of nitrogen, anybody?
14.
14. Nitrogen. N2.
28.
28. 28 is equal to 2 into vapor density. Now tell me what is the vapor density of what? Nitrogen gas. How much it will be? The vapor density of nitrogen gas. Out here marked molar mass of nitrogen. Vapor density of nitrogen. How much beta? Vapor density of nitrogen, how much it will be?
14.
14. It will be 14. Correct? My voice is audible, clear? No? My voice is
Yes,
clear
sir.
or not?
Yes.
Right. So this formula is useful for beta, for calculating what actually? Molar mass. Otherwise, what happens? Vapor density. If they given vapor density of any molecule, you can calculate the molar mass. Understood here? Vapor density is always half to the what? It's the molar mass. Understood? Right. Now let me see what happened. ideal gas will take. Based upon all we have discussed, how many laws beta now? Until now, how many laws we discussed now here?
3, sir.
You have Boyle's law, Charles law, de Lussac law, and Avogadro's law. Now, what I am doing here, I will compare all the gases now, except what de Lussac, leave it that one. Okay, I am taking the Boyle's law, Charles law, Avogadro. What is Boyle's law? Volume inversely proportional to pressure. Correct? Then Charles, volume directly proportional to temperature. Isn't it? Avogadro's law, volume directly proportional to number of moles here. Isn't it? Volume directly proportional to number of moles, volume directly proportional to temperature. Based upon this, what we can write here? Volume directly proportional to, isn't it, number of moles, temperature, but inversely proportional to what here? Pressure.
Pressure.
Now remove the proportionality. The proportionality, we get a proportional constant. That proportional constant I am writing R here. R is nothing but a proportionality constant. You see, it's a proportionality constant. It's a proportionality constant. R is a proportionality constant. You see, it's a proportionality constant. Now, in the place of proportionality, I put a constant R here. Next, what happened? NT by P. NT by P. Right? Now, we'll do one thing. I will send this P over here. What we get? PV is equal to, I'm writing nRT. PV is equal to nRT. This formula I got. This formula I got. PV is equal to nRT. Now, what is P here? Pressure of the gas. What is V here? Volume of the gas. What is N here? Number of moles of the gas. What is T here? Temperature of the gas. Now, what is R here? Proportionality constant. But all these things we are explaining for what? Gases. All these things we are explaining for what here? Gases. Therefore, it is called gas constant. It is called what? Gas constant. Now, if I take any gas, the R value will be same only, because a constant value for gases here. If I take nitrogen, oxygen, whatever I can take, the gas constant will be what? Same only. That is the reason what happened. It is called universal gas constant. Universal gas constant we can call this, because it is same for what? All the gases. Now, what is the value of the R? So, when you substitute the pressure value, volume, temperature, and number of moles, definitely we are going to get the R value. Now, R depends upon which value better? R depends upon what value? Pressure, volume, temperature. If you take what? Number of moles are constant. Now, what we know here, based on this, what happened? If three variables in these equations are known, if three variables in the equations are known, the fourth can be calculated. For example, you know the pressure, you know the volume, you know the temperature. Then you can calculate the number of moles of the gas. For example, if you know the number of moles of the gas, temperature, volume, you can calculate the pressure here. So from this equation, we can see what actually, isn't it? Constant temperature and pressure and moles of any gas, if I take, how to calculate the value? Based upon this one. Now we know that one R, T value we know, N value we know, P value know, we can calculate here value. Okay, so this equation can be applicable to any gas. Okay, not only what hydrogen, helium, you can take any gas, you can take what happened? This gas. Now this is called what? Ideal gas equation. It can be useful for what? Any type of gases. Therefore, it is called what? Ideal gas equation, useful for all types of gases here. Isn't it? Now, what is the R value here? How to calculate the R value here? How to calculate the R value? Now, R value is in terms of different units we can take. For example, I told you STP conditions, already I told you. STP conditions, already I told you. Temperature you have to take 0 degrees Celsius, that is nothing but 273.15 Kelvin temperature. And the pressure you are taking what here? 1 bar pressure. You are taking what? 1 bar pressure. Okay, and the value you are going to get 22.7. This is the 22.7 STP conditions. You are taking what? 22.7 you are getting. Then R value substitute here. Now, already you know that one. Yesterday only I told 1 atmosphere is almost all equal to 1 bar pressure, 0.97. That is always equal to 10 to the power of 5 pascals. So yesterday only I told you this one. So pressure I have taken in terms of Pascal beta. Pressure I have taken in terms of Pascal. Why? Because 1 atm is equal to how much beta? 1.01 into 10 to the power of 5 Pascals. Yesterday only I told you this one. Instead of 1 atmosphere, you can take what happened? 10 to the power of 5 Pascal. So take 10 to the power of 5 Pascal. And value you are taking what? 22.7 liter. 22.7 liter, and 1 liter should be equal to what? 10 to the power of -3 into meter cube. So this is equal to what? 1 liter actually. 10 to the power of -3 into meter cube is equal to what? 1 liter. Right? Now how moles have taken? Number of moles have taken 1 mole. Temperature have taken 273.15 Kelvin temperature. So after substituting the temperature, moles, pressure and volume in terms of Pascal, I got 8.314 here. But generally what happened, Pascal type of units they don't give in the problems. Most of the case they will give in terms of bars only, in terms of the bars only, or in terms of what? Joules, otherwise in terms of joules here. So you have to take 8.314, isn't it? In terms of Joule. So I am writing over here, if they given in terms of Pascal, what value take? Pascal. If the pressure, in terms of pressure only I am saying here, in terms of pressure, I am writing over here, all of you please observe here. The pressure, you have to observe the problems here. In problem, if they given pressure something, Pascal, they given pressure. What will be the R value beta? 8.314. Okay. If they given pressure in terms of what? ATM, atmosphere, you take R value equal to 8.314 into something. I am taking this one 0.0821. 0.0821. If they give in terms of what? Bar, R value will be 0.831. In terms of joules, if they give an R value must be what happened? 8.314. In terms of calories, if they give an R value must be taken as what? 1.987, but you take 2 calories. Roughly you take 2 calories. Okay. So R value, how many times you are getting it? 3 types you are getting. R value in terms of calorie, 2. In terms of joule, 8.314. In terms of bar, 0.831, because you are getting 10 to the power of -2, no. 10 to the power of -2, no. So substitute 10 to the power of -2, you get 0.0814. ATM we are getting 0.821. Why? Because 1 ATM is equal to 0.987. No, that is the reason we get small difference here. Okay, these are the values you ought to remember compulsory bit. All of you please note down these values in your notebook so that what happens whenever if you get a problem, it will be useful for you. Next thing, if you observe what happened, STP conditions. Early we taken what happened? 0 degrees Celsius, 1 atmosphere pressure. The value is what? 8.2 10 to the -2 means simply 0.0821. This is at STP conditions. Okay, this you have taken earlier actually. Now, ideal gas equation is relation between the 4 variables. No. Now it describes the state of any gas, therefore it is called what? Equation of state. Now you may get a question here, why ideal gas equation is called equation of state here? Why ideal gas equation is equation of state? Tell me beta, anybody? Why ideal gas equation is called equation of state? Now it relates what? 4 variables, which are what? Actually temperature, pressure, volume and number of moles, and describing the state of any gas here based upon these variables here. Therefore it is called equation of state here. So it describes the state of any gas here. So now based upon that this formula, PV is equal to nRT, right? PV is equal to nRT. Now what I am writing here, And I can write like this. If you observe what happened, PV is equal to nRT. Now what we'll take here? This temperature I'm sending over here. So what we get better? PV by T is equal to nR we get here. nR. R is already constant beta. R is already constant. N also you take constant. Take 1 mole here. Take, for example, otherwise you take what? If N is equal to 1, what will be the formula beta? If N is equal to 1, what will be the formula? If N is equal to 1 mole. For 1 mole of gas, what will be the formula beta? For 1 mole of the gas, what will be the formula? PV is equal to what? RT. This is for what?
RT.
1 mole of gas. For 1 mole of gas, we can take like this. For 1 mole of gas, the formula we can change PV is equal to RT. Now change this variable T over here. What we get here? PV by T is equal to R. PV by T is equal to R here. Now this is a constant value, no? R is a constant value, gas constant. Now based upon this, what we can write here? P1 V1 by T1 is equal to P2 V2 by T2. This formula is very, very useful for you. Very, very useful. So if you know this 1, 2, 3, 4, 5 variables, we can calculate the 6th variable here. For example, if you know P1, V1, T1, P2, V2, you can calculate the T2 here. Now this is now called combined gas law, because here we have Boyle's law is there, Charles law is there, Avogadro's law is there, all are there. Therefore, it is called a combined gas law. Now based upon this, we'll do a small problem better. We'll do a small problem now. We'll do a small problem here. Problem 5.3. Now if you observe what happened at 25 degrees Celsius, means it is T1 temperature. It is T1 temperature. 760 mm pressure, that means 1 atmosphere pressure, also called 760 mm of Hg. So you take pressure as in mm. T1 is in terms of mm. Now volume they given in terms of ml, so this will you take as a V1 beta. Now what will be its pressure? They are asking the P2 now here. They are asking what here? P2. P2 they are asking. At height where temperature is 10 degrees Celsius. Now temperature is 10 degrees Celsius. T2 it is. And volume of the gas is 640 ml. The volume is what here? V2. Now take here P1 is what? 760. V1 is what? 600 ml. T1 is what? 298 Kelvin. V2 is what? 640. 290 because you converted the temperature into what? Kelvin. And 283 you are converted the temperature into Kelvin. Now what is the combined gas law you are taking? This is the formula you are taking. This formula. This formula you are taking. Now in this one, P2 is equal to what happened? You send this one here over here and this V2 over here like this. Now we get a formula like this. Now substitute here. And substitute. Pressure how much here? 760. T1 is equal to 760. V1 is equal to 600 ml. T2 is equal to 283. And T1 is equal to 298. And finally, what happened? V2 is equal to 640 ml. So you got 676 mm Hg. Right? In this way, we have to do that. Understood better? But here one thing, if the given formula PVG, for a take 0.0831 or 0.0821 bar or whatever it may be, or atmosphere, take the pressure also in terms of bar and volume take in terms of liter better. So whenever you are using R value, whenever you are using R value, if R value taken as 0.0831, then volume must be taken in terms of liter, pressure must be taken in terms of what actually? Bar. Understood better? This is compulsory you have to do. We'll take one problem over here. Now this problem we get when you substitute that molar mass actually. Okay. Same problem we are having. This is what simple problem only. Volume, temperature, pressure. Now if you observe what happened, this one 5.2 you can do. A vessel 120 ml, temperature is given 35 degrees Celsius, pressure is given 1.2, gas is transferred to another 180 ml, 35 degrees Celsius. The temperature is constant here. Temperature is what? Constant here. What will be the pressure? Temperature is constant means what happened? Isothermal. So P is what happened? Inversely proportional to what? 1 by V. Boyle's law we can take for this. You can take what here? Boyle's law. Now in this case what happened? Volume is given and pressure is given. Isn't it? Next what happened? Volume is what given? V2. 30. What will be the minimum pressure required to compress? The temperature is constant here. The temperature is constant here. And what we have to calculate here? P2. It is also what again? Boyle's law. You can do Boyle's law, you will get this one. Now, 5.3 if you observe, using the equation of state PV is equal to nRT, show that the given temperature density of a gas is proportional to the gas pressure of the P. Now we'll do something what happened, a derivation for this formula, BV is equal to nRT. I will do a derivation for you. We'll take a derivation. Before moving to the next topic, we'll move to what? Some derivation. Before moving to this, let me see this derivation here. This derivation, let me see. From the ideal gas equation. Now already we know this one, PV is equal to what beta? nRT. Correct? This is the ideal gas equation. Now based on that, what I can write here, I am sending this RT over here. RT over here. Now what we get here? And V over here. V over here. Right? Now what we get here? N by V is equal to P by RT. This equation we get. Correct? Understood? Understood better?
Yes.
Now N is equal to what? N is equal to what here? Again, mass by molar mass. Mass by molar mass. Otherwise, what I weight by molecular weight. Mass if you represent small m, molar mass if I represent capital M. Now what happens here? In place of N, what we are taking here? In place of N, here value, what I am taking here? M by M. This formula you are getting here. Right? Now already we know one thing actually. Density is equal to, already we know density is equal to mass by value. Now in this case, 1 by V is equal to what we get, beta? 1 by V is equal to what we get? If I take 1 by V is equal to M will come where? D by M. Correct or not? Is it correct or not? Understood this one? D by M, this part. Shall I write 1 by V is equal to D by M? Shall I write like that?
Yes, sir.
Correct or not? So this equation what we are writing here, M by capital M into 1 by V is equal to P by RT I am writing. This equation I am writing. Shall I write like this, M by capital M? Shall I write like this equation? Say yes or no. Shall I write this equation like this?
Yes, sir.
Then 1 by V is equal to what beta? D by M, right? 1 by V is equal to D by M. So now put here what happened?
Sir.
Put here what happened here? 1 by V is equal to what we are going to get? Same P by RT is what same here? M. 1 by V is equal to what we are getting? D by M. Now we are getting what? M. 1 by V is equal to D by M. D by M. That is equal to what here? P by, isn't it? Now in this case, what I am taking here, this one actually what? Mass. This one is actually what? Mass. Right? This one. Mass it is. Here also what? Mass it is. Now mass get cancelled. Correct or not? What we get here? D by M is equal to P by RT. Correct? Now, based on this, what I am writing here, PM is equal to what I write? PM is equal to is a molar mass beta. Capital M is what? Molar mass, molecular weight it is equal to what here? DRT. So PM is equal to DRT. Remember this formula. Previous case, TB is equal to nRT. Now this one is called PM is equal to DRT. Now, based on this, M is equal to what I can write here? DRT by PM. Based on this, what I can write? M is equal to D. Now M is equal to here? Molar mass of the gas, molecular weight of the gas. D already you know density of the gas. R is what? Gas constant, temperature and pressure. So this formula will be useful, but you can't remember this formula. Better to remember PM is equal to what? DRT. PM is equal to what? DRT. If you remember that one, what happened? Very important. Now, based on this formula, we can calculate the molar mass of any gas if we know the pressure and the density and temperature. One more formula you got here. So this is the question we got at the last actually. This is they're asking in the last question we discussed. This one. Using the equation of the state PV is equal to nRT, show that the given temperature density of a gas is proportional to the pressure. You see here what you are written here. What is the density and pressure? What order we are going to get there? Observe here, pressure and density. You see, pressure and density. Pressure and density. Both are what actually? Directly proportional. You can say pressure and density both are what happened? Directly proportional. So in examination, you have derived like this. When you derive what happened, you will get it. Understood, beta?
Yes.
Derivation part understood. Derivation of ideal gas equation, this one. Previous case, we derived this equation. Derivation of ideal gas equation. This one is very important. 2 marks question better at this. 2 marks question. Derive an ideal gas equation by using the Charles law, Bayes law, Avogadro law. So you have to derive up to here. This is the derivation you have to go. This you have to derive. And derive the relation between the density and the pressure means you have to derive like this. This equation you have to derive. This equation. Right? You have any doubts better regarding this one? Do you have any doubts?
No, sir.
No, sir.
No. Now, see, let me see here a statement only. Tomorrow we'll do problems. Tomorrow we'll do all the problems. Okay. And I will just make a statement here that is called one more law, Dalton's law of partial pressure. We'll move to what now? Dalton's law of partial pressure. We'll see. Dalton's law of partial pressure. Let me see. Now, what is this Dalton's law of partial pressure? Very, very simple formula it is. Now, here I am taking for 2, and what I am taking here to explain this one, what I am doing here, I have taken, isn't it? In a container, I have taken 2 containers here. Now, here I have taken a X gas, or A gas A, here I have taken gas B. Okay. Now the pressure of the gas A is called PA. The pressure of the gas A is called what? PA. And the pressure of gas B is called PB. Okay. Now I mixed these 2 gases here. I have mixed these 2 gases here, A and B, A plus B now. Now in this case, the pressure of this one, the pressure here is always equal to, the total pressure here is always equal to partial pressure of A plus partial pressure of B. Now, if I add the partial pressure of A and partial pressure of B in this one, we get the total pressure. So this is called what? Dalton's law of partial pressure. Now, condition is that the A and B should not react with each other. The condition must be A and B should not react with each other. Now, what is the law you observe here? The total pressure exerted. The total pressure exerted. Exerted means what happened? The total pressure released by the mixture of non-reactive gases. This is important better. Non-reactive gases is equal to sum of the partial pressures of the individual gas. Sum of the partial pressure of the individual gas. isn't it? So, for example, you take it, the pressure which these gas would exert if they were enclosed separately in the same volume and under the same conditions. There must be what temperature must be same conditions. It should be what same volume and temperatures. Temperature and value must be constant in this case. It must be constant. Then we can write total pressure is equal to P1, P2, P3. For example, you are mixing 3 gases here. The total pressure of the mixture of the gases will be equal to P1 plus P2 plus P3. Understood here? So P total is the total pressure exerted by the mixture of the gas. The total pressure exerted by the mixture of the gases. And P1, P2 are the partial pressure of the gases. For example, I have taken here, you take this. You take this. This is the hydrogen. This is the helium I have taken. Now, what is the total pressure is equal to? We can write partial pressure of hydrogen plus partial pressure of helium is equal to what? Total pressure. Understood better? What is Dalton's law? Very important one. Formula also important one. Understood? Say yes or no.
Yes, sir. Yes, sir.
Next, we'll move to what small thing.
Yes,
What is
sir.
the aqueous tension? I will explain, and after that we get problems only. Okay. So I'll just explain this aqueous tension here. What is this aqueous tension? See, actually, what happens? Whenever you are collecting the gas, for example, you are preparing the nitrogen. You have prepared some ammonia. You prepare some gas in the laboratory. Now, where do you collect that one? In water. Over the water only you have to collect that. So when you collect that gas over the water, the gas will get moist. The gas will get what happened? Moist. That means the gas will have pressure of its own and what? Pressure of the water also. Because you are collecting that gas over water. No? So how to calculate the pressure of the dry gas? In that case, the total pressure you are getting minus aqueous tension. This P total, no, that also includes some pressure of the water also. That you are calling as what? Aqueous tension. What is aqueous tension? The pressure released, exerted by a saturated water. Vapor is called what? Aqueous tension. Why you are writing? Because you are making something what nitrogen gas or hydrogen gas, you are making that gas. But after that gas produced, you have to collect that one over the water here. When you collect over the water, now the pressure of that water vapor also including that pressure here of what? Nitrogen. So how to remove that one? Remove aqueous tension and we get dry gas. So this formula also very, very important. Total pressure of the gas which is collected over the what? Water. Total pressure of the gas which is collected over the water minus aqueous tension of water. Now, if you observe aqueous tension, if you observe what happened at different temperature, aqueous tension will be different. You see, if the temperature in this case, what happened? Increased here, isn't it? Temperature in this case, what happened? Increased here. See, temperature increased. Some 273 to what? 303 temperature is increased. Aqueous tension, if you observe what happened, also increased. So here, already know this one. T directly proportional to T. This based on lussac line. Based on the lussac law. The temperature increased, pressure also what happened? Increased to how much here? 0.04. So aqueous tension definitely will increase when you increase the temperature, right? Understood here?
Yes, sir.
Right. Tomorrow will be problems and this derivation also. Tomorrow we complete the Dalton's law and the problems and remaining problems containing in the Charles law, whatever we discussed at last stage. Now you do one thing. At last you are having some problems are there, and one more thing, beta, you the entire chapter is not there because of the reduction of the syllabus. We will discuss up to only ideal gas equation. After that, we don't have anything better. We need only up to here only. This is the last topic better. This is the last topic for us. Okay, tomorrow will be the last class for what actually states of matter, because remaining things were not there in the syllabus. Whatever it may be, remaining things are not there in the syllabus. Kinetic theory, everything is deleted. So we discuss only up to what? Ideal gas. Tomorrow is the last class. Okay, we'll discuss the problems and everything. and try to do some problems which is given in the exercise here, right? And I will discuss some problems over here in this. But because all things are not there, that is the reason what happened. Only I think something what here only 5.19 up to 5.19 is enough for us. Up to 5.19 is enough. Okay, if any miscellaneous questions will be there, we'll discuss that. Okay, you try some problems. You get any doubts, we'll discuss tomorrow, right? Now, how many students are there? 39. Net is not.
नेट नहीं है ये स्मूथ नहीं है या नहीं है
नेट नहीं आ रहा सर। कितने बेटा अभी? टोटल
53 sir.
53।
53 sir.
ये
खत्म हो गया सर। 10:30 के बाद लेता हूँ। कोई बात नहीं सर, 1 मिनट है, अभी हो गया सर। जस्ट अ मिनट बेटा, आई विल टेक अटेंडेंस। Just I'm reading the names. Abhishek Sharma, Abhishek Y, Aditya absent.
Present, sir.
Aditya absent. Akruti,
Present, sir.
Anshu,
Present, sir.
Anuj, Anushka absent. Today also she is absent. Anushka. Apurva, Atharva,
Present, sir.
Atul Rawat,
Present, sir.
Ayush,
Present, sir.
Bharti,
Present, sir.
Deepta,
Present, sir. Present, sir.
Jnaneshwar,
Present, sir.
Gulabi, Kalpesh, Kaushal,
Present, sir.
Krunal, Manoj,
Present, sir.
Present, sir.
Present, sir.
Mayur,
Present, sir. Present, sir.
Ojas, Omkar,
प्रेजेंट
Pallavi,
सर
Present, sir.
प्रेजेंट सर
Present sir.
Present, sir.
Omkar DM and Omkar P are present.
Present, sir.
Samiksha,
Present, sir.
Prathamesh,
Present, sir.
Raghav, Rahul,
Present, sir.
Raj, Ramya,
Present sir.
Riya,
Present, sir.
Rohit,
Present, sir.
Sahil,
Present, sir.
Samruddh,
Present, sir.
Sardak, Shashi,
Present, sir.
Sridhar, Sneha Ji, Sneha BS, Sneha BS.
Sir.
You stay after
Present,
the
sir.
test, you stay, don't log out. Sneha VS, don't log out. I want to talk with you.
Sir.
Sneha VS. Sonali,
Sir, you didn't take my name, sir.
Present,
Present,
sir.
sir.
Srihari,
Present, sir.
Sumit SD,
Present, sir.
Suraj absent. Suraj C and Suraj U, both are absent. Suraj C and Suraj U, both are absent. Triyambak, Vaishnavi J, Vaishnavi N,
Present, sir.
Vedant,
Present, sir.
Vaman, absent. Vedant, Vishal,
Present, sir.
Yash is there? Yes. Swastika? Swastika absent. Tejaswini absent? Present.
Present, sir.
Tejaswini. Just I am reading that absent is name beta. Just listen here. Swastika absent. Swastika absent. Vaman absent. Suraj C and Suraj U both are absent. That Dhanashree is present, no? Dhanashree is absent. Dhanashree, Patil Dhanashree. Absent. Chaitanya, absent. Anushka, absent. Okay, you can log out except the
Thank you,
Sneha
sir.
VS.
Thank you, sir.
Thank you, sir.
Sneha VS. Sneha VS.
Thank you, sir.
Sneha VS.
Yes, sir.
Present, sir.
Beta, why you are absent? Frequently you are absent. What is the reason?